Okay, so the upstream result within the DOCSIS result. This is the third test that makes up your DOCSIS result. And this is just one line of, this is one of the devices, and I've opened it up, and I can see the MAC address. I can see this is my XB3. It's a Cisco XB3, the DPC series, 3941T. And here's the other tests. Spectra we looked at, flux we looked at. This is upstream. Downstream's down here. We'll open that up in a second. But the other information that you actually get on each device, when you open up each device, it tells you lost syncs, resets if there are any. It'll give you a boot file. If it's a DOCSIS device, gives you the boot file and registration state if it's not complete or complete. But let's look at the upstream result. Right here again, light bulb should go off anytime you see those numbers, 17, 23, 30, and 36. These are your center frequencies of those individual QAM channels that the DOCSIS device is transmitting on. If I go back to our lovely frequency allocation chart, that's these. That's the upstream frequencies, the channels that these devices talk to Comcast on. So I can see they're all in the green. We're good to go. My transmit, this is the transmit power for each QAM. This is my receive power at the CMTS. The CMTS wants to see 0, so that's good. We're seeing 0. My actual power. Now the actual power is different from the transmit power. The CMTS wants to see 0, okay, on the receive power. The actual power is what would the modem have to transmit at to get this at 0? And here are some examples of actual power, better examples than this chart here. So that's actual power. The cable modem SNR, signal to noise ratio, 32. That's what this modem is at, 33, 34, 35. So you can see down by the lower frequencies it's a little bit messed up. Not messed up, just not as good. This is the port signal to noise ratio on the actual port at the CMTS. Here's some good information, T3 and T4 timeouts. And the T3 is usually like noise in the upstream that causes the CMTS to miss a ranging request, like it's almost like a roll call for the QAM or the modem, but drilled down even farther for each QAM, you can have T3 timeouts. And you can see that here. This one here, it's got a one T3 timeout. That's nothing. That's not really major. You start running into a bunch of them, then it's like, okay, something's going on. And your T4 timeouts are similar. A downstream issue can cause the modem to miss receiving a CMTS transmission, telling it to transmit one of those roll calls, the ranging request, within the T4 timeout period, and that's there's a certain window that it has to send that. So, and we're good there. So, but if you see T3s and T4s, a lot of them, that's another diagnostic tool you can use to say, hey, something's going on in my upstream. It's really jamming up my upstream because it's timing out here. The CMTS is not getting the ranging request from the device itself. Your registration state should always be number 4. Anything other than 4 means that it's not bonding properly. It's not utilizing channel bonding for the upstream channels. And channel bonding is one of the ways that we disperse traffic, modem traffic, throughout a node. And it's also the main reason we can get higher speeds, more transfer of data because we're increasing the bandwidth. It's almost as if all four are acting as one in many ways. And here's an example. Okay, I came up with this to help us conceptualize channel bonding for those of you that are not really sure on what is going on with channel bonding. Imagine if I had to do, and we'll keep this in the realm of the forward, okay, so coming from Comcast to the device. But it works both ways. It works also on the return side. But imagine if I had to deliver you a whole pizza, okay? With the old way of doing things, I could only deliver one slice at a time. I'd deliver one slice, then another slice, then another slice. The escalator is a QAM channel, okay? That's the channel we're using. And the old way was I can only do one slice at a time, and that could take a while to get a whole pizza delivered. Then with channel bonding, we use multiple channels at the same time to deliver a slice. So now you can see how speeds can increase, 4 channels, 8 channels, 16 channels, all at the same time. Now, instead of waiting for one slice at a time, boom, I can deliver the pizza much faster because we're using multiple QAM channels to deliver information rather than just using one and waiting and sending another block of information and another block of information. And that happens on the downstream from Comcast to the device. And it also happens on the upstream from the device to Comcast. And that is basically your upstream result.